All right, so question 1 and 2, obviously true because we're all here. Question 3.
Hang on, real quick. I gotta put something in the oven real fast.
Oh, you're good.
Okay.
My wife found a recipe for 4-ingredient lasagna, so basically a cheater lasagna.
Oh.
Wow.
Sorry, guys, I have like this mask thing in my hair. So my hair is all like gross looking right now.
You're okay, Jocelyn.
I'm sure you guys don't care, but
Don't worry.
just so you know what's going on with my hair.
Yeah, I don't think that was too much of a concern. I'll be honest with you. We love you, but I think that
I love you guys. Okay, let's
was...
do
All
this.
right.
Okay.
So, question 3. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Hold on a sec.
All right. So I have the book open. If it's right skewed, did anybody use the
Applet?
yeah, the applet?
I didn't.
Yeah, I did.
Yeah, because doesn't that show that it was right skewed?
Yeah.
Okay.
Will
So then wouldn't the answer be
mark
right
it
skewed?
with skew? Okay.
So is that our answer, that it's going to be right skewed?
I guess, but I think I read something saying that if we have a small number less than 30, it's going to be a normal.
Mm-hmm.
So let me check that out.
It still comes out normal, because I just ran the applet with it skewed, and it still comes out normal. It's just the mean is over, is a lower mean, but if it's right skewed, it still comes out normal.
Because of the number, right? Of the size. Okay.
Yeah, it's in 3.1.
3.1?
Okay.
So how did you put it into the applet?
I just, on the applet, I just changed that first one to skewed, and it automatically makes it skewed right. And then you click the animation, and I did animation at 10,000. So where it says clear lower 3, change that normal to where it says just show it skewed. And then I just on the next one where it says sample, I just hit the 10,000, and below it, it shows it as normal.
Yeah, it's normal.
Okay. Gotcha. Okay, yeah. So it is normal then. I agree with that. Does everyone agree with that?
Yep.
Yes.
Perfect. Okay. When you're taking the sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Now let's see.
I may be overthinking. I want to say it's normal again, but
I would think so too.
because we just ran one with it right skewed and it came out normal, and it's still talking about the histogram. Sorry, my dog thinks he's all big and bad. He's sitting in the window growling at people walking outside the house.
Oh,
it's okay.
Kazi. All right. So question 5.
okay.
Question 5, when you are taking a sample size of n equals 5, what's the shape of the histogram when the parent population is normally distributed?
Normal.
Well, if it's normally distributed, then wouldn't it come out normal?
Yeah, it is normal.
Is what I think.
I think we're missing something somewhere. I agree, but it seems too obvious that these 3 questions in a row are all normal.
Can we go back to number 3?
Uh-huh.
Okay.
Sure.
So when we put it in the applet, it's skewed normally, is what we're saying.
Right. Yeah, because we all ran it, and it's skewed normally.
Okay.
Am I missing something there?
I don't know. I don't know. Maybe.
I mean, I can tell, Jocelyn, you're getting the same feeling I am. It seems too obvious for all 3 in a row to be normal.
Yeah. I just.
Abraham, are you looking at the book?
Yes, I'm looking.
Actually, I am.
It
says when it's normal, if the parent population is normal, then the sample distribution will always be normally distributed, no matter how many observations are selected.
All right, so 5 is definitely normal.
Yes.
Yeah.
Yes,
all right,
5 is normal.
So what about
3 and 4?
3 and 4 when it's talking about right skewed?
It says for most moderately skewed distributions, a sample size of around 30 is traditional thought to be sufficiently that will be approximately normally distributed too.
Oh, so they'd be normally distributed as well. Then is that what I'm getting from their reading?
But it says something about 30. So I'm assuming if it's bigger than 30, then it's normal. 30 or bigger, it's normal.
So 4 would then be normal then.
Right. But then what would 3 be? Because it's less than 30. Does it say anything about less than 30?
Let me check. It says if the sample size is at least 30, we will conclude that the sample distribution will be approximately normal.
Okay. So since it's not, and it's right skewed, then I'd assume it'd be skewed right still.
Yeah, since it's less than 30, I think I follow your logic there.
For 3?
Yes.
Yeah.
Okay.
So I mean, I think number 3 will be skewed right, and then 4 and 5 will
The other
be.
one is gonna be normal. Okay.
You're right. Yeah.
Does everyone agree
Okay.
with that?
Yeah.
Okay.
It makes sense.
Okay.
Okay, so the number 3 is skew right.
Right.
Yes.
And number 4
would be normal.
And so number 5 too.
And then number 6 is going to be normal as well because it's already normally distributed.
Okay.
At least that's what I think.
Right.
And then number 7, when would the distribution of means be normally distributed? Well, all the normal ones. So 1 and 2. And then the last one, because the size is large.
Yes. Agreed.
So, okay,
So
the third one is not the right one, right?
Yeah, number 3, leave number 3 blank.
Right. So the one that says data are drawn from a population that is right skewed and the sample size is small. That's the only one that wouldn't be. For number 8, let's see. Which of the following gives the best explanation of the central limit theorem?
Okay. I think is C.
If the sample size is large, the sample mean will be close to the population mean.
Is it the central limit theorem? Bell curve. I would think it's the second one because in the reading it talked about it being bell-shaped.
Yeah. That's what I was just going over right now.
So I mean, that's just what I think. I don't know what if you guys agree with that or not.
Also, the last one, it says if the sample size is large, the shape of the distribution of sample means will be approximately normal. And also, it says that on the reading.
Yes, in 3.1, in 1, 2, 3, 4, in point 4. You just have some dots.
Where it says if the parent population is heavily skewed.
Is that the one you're talking about, Abraham?
Sorry. Yes.
Okay.
Yes.
I was talking about this part of the reading. You can read. I just sent it to you guys. Oh, well, I sent in the wrong one.
Uh-oh.
Here it is.
The sampling distribution
there it is.
sample mean will be approximately normal if the sample size is sufficiently large. Okay.
So then it's the last one then, according to that definition, is that right?
I don't know what you guys think.
No, because you got that right out of the book.
Yep.
Well, if that's the the definition the book is giving, then that's the one we should go with.
Right, I agree.
Yeah.
Okay.
And then if it's wrong,
So
we'll go from there.
Mm-hmm.
Okay, so this next one says, let X be a random variable with population mean equaling 10 and population standard deviation equaling 6. Suppose the sample of size 36 is drawn from this population. What is the mean of the distribution of sample means?
Oh, okay.
10. Because it says, what is the mean of the distribution sample means? So the distribution sample means it's the same that the population means, so it's going to be 10. I just watched the video.
Okay.
It's going to be 10?
Yeah.
Oh, yes, yeah. It's going to be 10.
Oh, yeah, duh, because it's the mean. Okay, perfect.
Yeah, it's the same.
Right.
And then the standard deviation will remain 6.
Mm-hmm. Exactly.
Perfect.
And the other one is going to be 6 divided by 6, 1.
Yeah. 6 divided by what?
So the formula is going to be the standard deviation divided by the number squared. No, I mean the.
Oh, are you looking at
36.
Root? Yeah, the square root.
Yeah.
The square root of 36. The samples. The standard deviation of the sample. So 6 divided by 6 equals 1. Because sometimes it's large. No, that will be the shape distribution.
So is it using the formula that's there in section 4 of the reading?
Mm-hmm.
Okay.
Let me check. Yeah, that's the formula.
Okay. So in ours, so what we would be looking at, if the sample size is 30, and according to the formula, it doesn't matter the sample size. Is that right? Yeah, it doesn't matter. According to that formula, it doesn't matter the sample size. Because it's just taking the standard deviation times. No, it does.
Well, actually,
okay, the square root of the
number.
sample size. Right.
It doesn't mean the mean. It doesn't matter, but we're using the standard deviation and the number of the sample.
Yeah, that's right. I was just reading it. Perfect. So for this question, so we're taking
the standard deviation of the sample is going to be 1.
Standard deviation is going to be 6 divided by
square root of 36.
The square root of 36, which would be 6. So you're correct. It's 1.
So number 11 says, regardless of the distribution of the population, if the sample size is large, what will be the shape distribution of the sample mean? So
if it's less than 30, then it'll be.
It would be right skewed then.
Yeah.
Okay. And question 12, it says, what theorem will justify your response to the last question? It's going to be central limit theorem. So.
Right. Agreed. Because they didn't talk about the large number law.
No, yeah.
Okay, I'm going to submit mine. Everyone.
Okay.
Okay.
Let's see. Okay, we missed one.
Which one did we miss?
Number 11. It's not right skewed. Oh, it's because the size is large. It's not less than 30. It's more than 30.
Oh.
It's normal skewed.
So it's normal. Right.
Okay.
Gotta pay attention to the sign.
0.6.
Of course. Okay, let me go back.
I'm trying to save all my responses in.
What, you didn't need to read the responses?
Yeah,
What?
I'm gonna need the responses in a second.
All right. Let me know when you're ready.
Thank you. Give me one sec. Okay, first and second true. You said skewed right. Normal.
Correct, skewed right. Then normal and normal. 6 is also normal.
7 was first, second, and fourth.
Correct.
8 was the last one.
Correct.
9 was 10. Was 1.
Well,
sorry. 10 was 1.
10 was 1.
Is normal. And central limit theorem. Okay, let's see.
And it's correct.
I got one wrong, I think. I don't know why. Oh, let me check.
Which one?
7 and 10. That's weird.
10 is 1.
Let me check again. I'm gonna retake it, so just hold on.
Question 10 is 1 because I have it as 1 and it came out right.
Yeah, same.
10 is 1?
Yes, 10 is 1.
Okay, let me just try to do it again. One second, it's loading. Oh, it's taking forever. Okay, so number 3, it's gonna be skewed right.
Number 3 is skewed right.
Okay. Number 4, it's normal.
It's normal.
Number 5 is also normal.
6 is normal too.
Okay. 7. I mark the. Which one do I have to mark first?
Go ahead, Jocelyn.
So all of them, but the third one that mentions small numbers.
Okay. So it's gonna be 1, 2, and 4, right? It is gonna be the last one. Right? If the sample size is large, the shape of the distribution. Okay.
Yep.
9 is gonna be C. 10. Okay. 10. 10 is gonna be 1. Oh. Is it 1?
Yeah, it's 1.
Yeah.
Okay. 11. Normal. And 12, central limit theorem.
There you go.
True and true. Okay. Okay. Perfect, guys.
Sweet.
Cool. We got.
All right.
Okay,
Well,
so
that was an easy one.
yeah,
That was easy today.
it was
Nice.
really
We
easy.
even finished under like an hour.
Right. All right.
I can't believe it.
So do we want to meet again on Thursday?
Yes, Thursday. What time works for you guys?
This time works for me on Thursdays. What about you? What about Abraham and Glenda?
Oh, well, actually, I can do it. Whatever, doesn't matter for me. But I think Abraham has the pathway meeting. So
Yeah. So what time for you, Abraham?
On Thursday, church, but I don't know if the internet connection works well.
Okay. Well, we can just wait till you get home if you want.
Do you want to do it? So you get home about 9 then? Is that right?
Yes.
okay, we can do it at that time.
Yeah, we can do it 9
Yeah,
o'clock.
we can do 9. That way you don't have to
Are
rush
you planning?
and you can get your stuff done.
Yep.
All right. So 9 o'clock on Thursday then.
9 o'clock Thursday.
Perfect.
All right, guys. Thanks.
Bye, guys.
Thank you,
Have a good
guys.
one.
Bye.
Okay.
Bye.
Thank you. Bye.